Hi, everybody. My name is Caroline Schaake, and this is my project on optimizing sustainable energy through a CAD-driven solar microgrid simulation. As we know, in Hawaii, we face some of the highest energy costs in the nation due to our reliance on imported fossil fuels. My project focuses on Kalani High School as a case study for decentralized power. I designed a multi-model PV system featuring 3 distinct arrays: a rooftop, a parking canopy, and a ground-mounted solar farm to see if a local campus can move toward true energy autonomy. My goal was to move past theoretical solar and create a validated blueprint for a functional microgrid. The design process began with a 3D CAD reconstruction using Aladdin of the campus. I chose Kalani High School gym, and this program allowed me to perform a detailed shading analysis. I had to account for existing buildings and foliage to ensure the arrays were placed for maximum irradiance. Rather, iterated through several configurations for the rooftop canopy system, adjusting tilt angles and panel spacing within the simulation software to optimize energy density. Utilizing these simulations to handle complex electrical interactions of 3 arrays, these simulations process through thousands of data points, including hour irradiance and temperature profiles specific to East Oahu. To make this data actionable for grid integration, the entire campus is modeled as a Thevian equivalent circuit. By taking the complex simulated outputs and simplifying them into a simple voltage source and an equivalent resistance, we can accurately analyze how the school interacts with the HECO utility grid. This modeling tells us exactly how much push the solar system provides and how much resistance the campus network introduces during peak loads. The results of the simulations were significant. If you look at figures 5 and 6, which are right over here, we go. I got figure 5 and 6. The system projected to yield over 1.2 gigawatt hours per year. The testing verified our seasonal reliability. We hit a hit peak of about 47,000 kilowatt per hour in August and maintained a solid 26,000 kilowatt hour in December. By analyzing individual panel performance in the simulation reports, I confirmed that our design successfully mitigated shading losses, proving that the system remains efficient under less than ideal environmental conditions. Ultimately, this project demonstrates that urban campuses have the vertical and horizontal real estate to achieve energy independence. For future work, the next step for this research would be integrating a battery energy storage system. You can kind of see it in this figure over here. I have some in my solar farm. There's a couple here, and then 2 also around the parking canopy. This would allow us to store that midday excess power and discharge it during evening peaks, turning Kalani High School into a resilient emergency power hub for East Oahu community during grid outages. By using simulation and modeling to solve local energy challenges, we can build a more sustainable future for Hawaii. And that's my project. Thank you.